Okay, so first we will be going over trigonometric ratios and the Pythagorean Theorem. And the standard assessed is using trigonometric ratios and the Pythagorean Theorem to solve right triangles and applied problems. The learning objectives is that learners will demonstrate their understanding of trigonometric ratios and the Pythagorean Theorem by solving for sides and angles in right triangles with real-world problems and groups on their own. So previously we had talked about similar triangles and like the sides of triangles, so they know what the hypotenuse and the sides of triangles are. So students will discuss, as the anticipatory set, the importance of finding the sides of triangles and its relation to real world. And this will promote intrinsic motivation, as they will hook them into like knowing that what they're going to learn will be used in real life, and it is very important. And then so they will, after we share everyone's ideas, they will quickly go through this Desmos activity. This technology allows them to draw lines such as this and work through this problem, and they get to explain their own reasonings for why they do things. And this will allow me to share as a teacher everyone's responses so that we can see the different academic language used through their responses as they need to use that, and I will promote that in discussion of that opening thing. So they will go through a couple different ones on here, and then I will start to demonstrate this. So first we will discuss the Pythagorean Theorem, which they know what the equation is, and they know what the sides and the hypotenuse is. So first we will just go through this demonstration together of the two sides we know are A and B, and that's in this equation with C. So the 3 and the 4 will be plugged in for the A and B, and so that will be the 3 squared plus 4 squared equals the C squared, and that will go into the 9 plus 16 equals C squared, which is 25, which is equal to C squared, and the square root of 25 is 5. Then we will go into the trigonometric ratios, and I will keep this slide up for students to look through, and we will go into GeoGebra for students to look at how to do this, and we will identify steps. And the first step is we will need to identify this reference angle. And why is that one the reference angle? Could someone tell me? Yes, okay, perfect. So we identify this as the reference angle, so then we're going to have to identify what trig ratio we need to use. So we have this angle and a side, and we need to find AC. So if you know you have this angle and this side, you have the adjacent side, and you need to find the hypotenuse, so you will use cosine. After this, I will allow them to do a few more problems on GeoGebra and then give them time to work on a problem in their group and present it on a whiteboard. And the presentation will also adhere to some English standards of presenting to a class. And they will solve the problems differently and discuss it with academic language on how they arrived at their answers. And yeah, that's it.